Hello, my name is Nikita Rayleigh, and I'm going to be doing homework 11 for Intro to Biochem. For this homework assignment, I will be analyzing turning a riboflavin binding protein into a self-sufficient monooxidase by cofactor redesign. The purpose of this article is to see if a monooxygenase they can make a monooxygenase capable of bypassing the step that needs NADPH reduction, and so that it can just have hydrogen peroxide reduction. This can be seen in the scheme 1, and this would be the normal reaction right here, all the way around, and scientists are trying to see if they can bypass this step right here by creating a monooxygenase that can go through hydrogen peroxide reduction and then continue on through the sulfoxidation step this way. And how they did this is by cofactor redesign, which is changing the R groups on the sulfur atom right here. So they're changing the R1 and R2 to different groups to see which one is the most efficient depending on this molecule up top. The approach that authors took to do this was to do multiple trials with different flavins and different groups to see which one had the best production. And to see this production, we go to table 1. In table 1, you can see that they did 19 different trials or experiments with different R groups and with a different flavin. And as you can see, this row is flavin 2, 3, 4, 5, 6. And then you can see the R groups right here and how they change with each entry. What this table shows is that this is the conversion rate of using these different things to complete the reaction. This is the conversion percentage, and you can see there is a 40% for flavins 3 through 5, and then at flavin 6 down here, you can see that there is a over 60% conversion. And then in this last column over here, you can see which sulfur remained with the R or the S and how much was left. From this data, scientists were able to conclude that the different flavins and the different R groups were able to produce a reaction with a pretty high efficiency, especially around 60. And they were able to see that these could act as catalysts and that the reactions could proceed, and cofactor redesign was effective for this specific reaction, even though the efficiencies aren't very high. Overall, scientists conclude that this method of cofactor redesign can be useful in the real world, and it can bypass something that is very expensive to make something that is potentially cheaper for companies to do. That is the end of my analysis for this article. The end.